lecture. So let's say where are we? Uh, we're supposed to start chapter 5 this week. So chapter 5, I'm going to start actually one lecture behind. And computer assignment number 3. I will be hosting computer assignment number 3, and it is going to be on chapter 4, continuous random variable. Today I am going to, my plan is to finish chapter 4 and then start chapter 5. Chapter 4, one important topic that I did not discuss, so I'm going to discuss that today. Also, most of you brought laptop, right? Today I have one extra credit problem, but you don't have to do it today. Okay? You can, there is a bit of extra work that you will need time to work on. So I'm going to, part of it you will do it today, but you can just submit the Python code and sign the sign-off sheet after we come back from spring break. Next week is the spring break, right? All right. So you will see what problem that we'll talk about. So I included all part 1. Like this course consists of 3 parts, guys. One is the title of the course is Probability, Statistics, and Random Processes. So I included all the topics of part probability, which is chapter 1 to 5. Okay. So chapter 5 topics are included in the current version of my lecture slides. This I do not have planned to change the topics that are included in my slide, but down the line I will just change cosmetics, for example, drawing a figure and then adding more examples. That's all. But as far as the theory is concerned, chapter 5 slides will not change, so you can prepare accordingly. So chapter 4, let's finish this topic. So it's just one topic that is left, which is function of one random variable. Guys, the other thing that you will notice that I'm going through function of one random variable. Chapter 5, chapter 5 is about 2 random variables. Okay, chapter 5 is about 2 random variables. Chapter 6 about n random variables. But chapter 5, all the topics that we'll cover in chapter 5, we covered those topics in chapter 4. Only difference in chapter 5 is that we will talk about 2 random variables instead of 1 random variable. Is that clear? So that's why chapter 5 will not take much time because topics are very similar to chapter 4 and chapter 3. So this function of a random variable in chapter 5 we'll talk about function of 2 random variables or vector random variable. So if here in this topic, the main idea for this topic is, yeah, I have the theory, but please try to understand the main idea, what we are trying to do. We have a random variable. We have a random variable. This random variable could be Gaussian, could be any other, could follow Gaussian distribution or can follow exponential distribution, whatever, any other distribution. Okay, so but it's a continuous random variable. Let's say for the sake of simplicity, it's a Gaussian random. X is a Gaussian random variable with parameter mu and sigma square. Okay, so if x is a Gaussian random variable, now we know the range of x. Range of x, which is range of x, we denote it with s sub x, which is basically negative infinity to positive infinity. So this is the range. So this is known. We know this. Okay. And also what is known is PDF, f sub x, which is PDF, f sub x, x. This is also known, because this is a Gaussian random variable, that's why we know that it is 1 over sigma square root over 2 pi, and then e to the negative half x minus mu over sigma square. Yeah, x minus mu over sigma square. Okay, so this is PDF. The problem is, this is known. This is also known. And also, another quantity that could be known is f sub x. F sub x, which is CDF. CDF, and it is by definition probability that x less than or equals x, which is basically integration negative infinity to x, f sub x as ds. Okay. So these quantities are known. We know the random variable, we know the distribution of random variable, we know the distribution of random variable, we know the range of the random variable, we know the PDF of the random variable, we know the CDF of the random variable, and also we know the function of this random variable, which is g of x. This is known. And we call this y equals g of x. So therefore, because this function is known, what we need to find, the main idea here, need to find range of y, because y equals g of x. Since x is a random variable, therefore the function of x is will give you a random quantity. So therefore y is a random variable. We need to find s sub y equals what? We need to find what is PDF of y, f sub y equals what? We need to find CDF, which is f sub y equals what? So given the function of the random variable and given all this distribution of random variable x, we need to find this quantity. And how to find it? So this is what I mentioned. So the way you find is first range of x and y, because range of x you know, you should be able to find the range of y given the function. So you find the range of y, and then you find the inverse of this function, which will give you the x. So if you have y equals g of x, one thing that you notice, the function itself is deterministic, but the argument is random variable. X is a random variable, but the function itself is deterministic. It is not random. So for example, in the next example, you will see ax plus b, ax plus b. So this function itself, this configuration is fixed, not random. Okay, in some cases you will see that function itself could be random. That is more complex. But here, the function itself is deterministic. Only random variable, the variable is random. So once you have that, then you can find x, which is basically g inverse of y, which is going to be a function of y. So you find it in the form of probability that x less than or equals g inverse of y. And we know that, look, probability of x less than or equals x is basically f sub x, which is the CDF. And this argument is right here. This argument is right here. So therefore, you have this argument, you can consider this as x, and this x goes right here. Because you know the CDF, because this CDF is known, this function is known, you should be able to just pass the different argument to find the CDF of random variable y. So random variable y, you find the CDF as such. So we will be using this formula to solve this example. So let's go through this example. So we have x is a continuous random variable, but we do not know its distribution. Only thing we know is we do not know its uniformly distributed or uniform random variable, exponential random variable, or Gaussian random variable. We do not know. Only thing we know that x is a continuous random variable with CDF f sub x, and let y equals, this is your g of x. Now your g of x is known when x is a random variable, therefore y is a random variable. When a is a real number, a is an element from the set of real numbers, a is not equal 0, and b is also a real number. Find the CDF of y, f sub y, when a greater than 0, a less than 0. So let's solve this example. We will be directly utilizing this formula. We will be directly utilizing this formula. Look. Solution. The notation, please don't forget the notation here. So when you have y equals g of x, you can write x, which is inverse of x equals inverse of y. You can apply the g inverse operator both sides. You get x, this argument equals g inverse of y. And this is, see how the interpretation is. So given y equals ax plus b, you just find x in terms of y. So x is going to be y minus b over a. And this is a function of, this is basically g inverse of y. This is function of y. So please don't be scared with this notation, g inverse. Okay, it's basically finding x in terms of y. That's all. Which is if the function itself you can find unique solution, then it's a piece of cake. Now CDF of RG y, which we denoted with f sub y equals probability that y less than or equals y by definition, equal, this is equal by definition. So the way you read it is, this symbol is equal by definition. Equal by definition. Okay, so now look. I am going to substitute the expression for y. So it is going to be y is going to be a random variable x plus b less than or equals y. Which is, I'm going to write probability that x less than or equals lowercase y minus b over a. This is where the trick is. Okay. Now, did I say that CDF of RV x, f sub x is known? Yes, I did say. CDF of f sub x is known. So therefore, f sub x, which is by definition probability that x less than or equals x, is known. Now look at the similarity here. So here, this probability, this notation, and this notation. You have x here, you have x here. Instead of lowercase x, you have y minus b over a. So therefore, what you can do, because this function is known, I can write, which implies f sub y, I'm writing this quantity, f sub y equals probability that x less than or equals x, I can write it in terms of f sub x. The argument is y minus b. So, argument here is y minus b. Now, because this function is known, we went through this CDF, this function is known. In this function, you just pass this argument, y minus b over a, that's all. And I am going to write number 1, if a greater than 0, if a greater than 0, this inequality holds. If a greater than 0, this inequality holds. So if a is positive, this inequality holds. If a equals 0, f sub y is simply f sub x, y minus b over a. But if a is less than 0, so this inequality would be flipped, would be completely flipped. If a is less than 0, if a is less than 0, if a is less than 0, look at the inequality. Then dividing, I'm just writing a little bit, dividing by a reverses, that's where you need to pay attention, reverses the inequality. Which is a x plus b less than or equals y. Do you know what this symbol is? What this symbol is called? It is bidirectional arrow.
No, I don't know.
You just know that it's a bidirectional arrow, right?
Yeah.
Do you guys know what is this IFF?
If and only
If, very good, if and only if. So this bidirectional arrow means it is if and only if. Okay? And in later, the command is just IFF. So you can actually write in Markdown. In Markdown, you can just use this later command to generate this bidirectional arrow. Now, I said that this a is strictly less than 0. Because a is strictly less than 0, what will be the inequality, guys? X y minus b over a. What will be the inequality? Less than or equals or greater than or equals? Okay, I said that A is less than 0. A is greater than 0, that's okay. So inequality follows. But if A less than 0, what would be this inequality?
What's the greater?
It is going to be flipped. X greater than or equals y minus b. And here, you pay attention here. Now, therefore, f sub y is going to be becomes probability by definition y less than or equals y, which is probability that ax plus b less than or equals y. Okay, because a is negative, it is probability that x greater than or equals y minus b over a. Now you cannot write it in terms of CDF, which is not straightforward. But what you can do, the trick here is that probability that x greater than or equals certain quantity is 1 minus probability that x less than or equals less than or equals, doesn't matter, because I put greater than or equals, I put less than here. So y minus b over a. So now you can write this as f sub x y minus b over a. You can just pass this argument. So therefore, when a is negative, you have 1 minus f sub x y minus b over a. So this is the final answer. So when a is negative, that's where this computation arises. When a is negative. So in the exam, what I can do, you may not see the CDF of random variable x as a function. You will have explicit expression given the explicit. You see that? And you know that CDF has some explicit expression, right? You remember that CDF. So CDF of random variable x equals certain quantity if less than 0, right? And then certain quantity if a less than or equals x less than or equals b, and then all the way to 1. You remember when x greater than b? Do you remember? So you will have this explicit expression instead of leaving the function itself. So in that case, you will have to pass these parameters with numerical values of a and b to this function and write the explicit expression. And that's what you will see in the following example. So in the following example, I gave you, in this example, I gave you that x is a uniform random variable. In the previous example, I did not say that x is an uniform random variable. It could be any random variable. But here, in this example, x is a uniform random variable, AB, and then S sub x range is going to be AB. This is your range. And you know the CDF. You know the CDF f sub x x. Do you know the CDF of f sub x x for uniform random variable? It is 0 if x less than a. It is x minus a over b minus a if a less than or equals x less than b, and it is 1 if x greater than or equals b. That is the explicit expression of CDF. So this is known, and you also know y equals g of x, which is e to the x. So you know the exact function. Now, how to find CDF? I'm just going to directly write down the answer, guys, because I need to cover some other topics. To find CDF, this is solution given this. Now we need to find how to connect it to the D2. Here, we need to find what is f sub y. Y equals what? Look, you need to find the range. Range of y. S sub y. Okay, you know the range of x, right? Range of x a all the way b. But because y is a function of x, you substitute e to the x, you substitute the lower limit of this range, which is e to the a, and the maximum is going to be e to the b. So this is the range of y. So that's how we find the range of y. And then you need to find x equals g inverse of y, which is basically, okay, what is x in terms of y, guys? You take logarithm, right? Natural logarithm?
Log, is y equal to log x?
Yes, natural logarithm. X equals natural logarithm. You take logarithm, right?
Yeah.
Natural logarithm of y. So this is your x equals g inverse of y. So you now know this. Now I'm going to directly write f sub y, which is by definition probability that y less than or equals y, which is probability that e to the x less than or equals y, which is probability that x less than or equals, you take logarithm, x less than or equals natural logarithm of y, which is f sub x, argument is going to be natural logarithm of y. That's it. Now you know the exact CDF, you just substitute instead of x, you just substitute logarithm y. So which is basically 0 if y less than e to the a, it is logarithm, natural logarithm of y minus a over b minus a. If e to the a less than y less than or equals y less than e to the b, and it is 1 if y greater than e. You can put less than here, you can put greater than equals. Yeah, that's all. So here I made it short, very short. The difference between previous example and this example is that here we know the distribution of the random variable, and in this example we know the explicit expression of C. So therefore it is not in the form of CDF of random variable x only. So you have explicit expression. So in the exam you may expect problems like this, where you have you'll be given the distribution of a random variable. Which random variable? It could be Gaussian, it could be a uniform random variable, it could be exponential random variable. Then you find what is CDF. Now the other topic that I will go through is method of transformation. Okay, so before I read my slide, guys, so try to understand the main idea here. Method of transformation. Try to understand the main idea, method of transformation. What is method of transformation? Okay, guys, we know the known quantity x could be any random variable. This is given. You know S sub x, range, okay, and PDF, probability density function of F sub x. These are known quantity. Also, what you know is y equals g of x. This is also known. This function is also known. So y is a function of x. So here, yeah, try to understand the main idea because the formal methods are there in my slide. Look, what does method of transformation do? When you want to find the PDF of certain quantity, when you want to find the PDF of certain quantity, in this case, we want to find the PDF of y. So the PDF of y is basically to find PDF of y, you need to find the CDF of y first, CDF of y. So cumulative distribution function of y. Once you find this, you take the derivative of CDF of y. You take the derivative of CDF of y to get this PDF. What this method of transformation does is that you do not need to find the CDF of y. You do not need to find the CDF of y to find the PDF, because by definition you need to find CDF to find the PDF, because the PDF is basically a derivative of CDF. So this quantity needs to be determined first before you determine the PDF. Yes?
Can you integrate the PDF to get the CDF?
Yeah, but in that case, you need to find the PDF first to find CDF.
Yeah.
Okay? By definition, it is the opposite. You find the CDF and then you take the derivative to get the PDF. So that's where we covered CDF first. But to find the integration, to find CDF, you need to just integrate the PDF to find CDF. Now, the method of transformation, what it does, you do not need to integrate or you do not need to differentiate to find the other quantity. Given this PDF and this function, you should be able to directly write the PDF, skipping the intermediate step. Okay, and that is the main idea of this topic, and I actually gave you the formal definition here. So the condition here is that this g of x has to be strictly monotonic differentiable function. Monotonic means strictly increasing or strictly decreasing. It cannot have a flat. It cannot be a flat function. It cannot be a constant function. Okay? It has to be strictly increasing like that, or strictly decreasing like that. So if that is the case, then you can differentiate g of x with respect to x. And also you can actually find x in terms of y. It is well defined. It's unique solution. Then only after that you can find the PDF directly as such. So where you know the probability density function of random variable x, you pass this inverse function and then you take, let's say, y equals ax plus b. So therefore x equals y minus b over a. So dx over dy, dx over dy is basically 1 over a. So that's what it means. Dx over dy, you evaluate it at x equals this quantity. So you directly use this formula to find the CDF. And I will have some homework problems related to this as well. And I have one example right here. So here, I'm just going to write down in short the solution here. Y equals ax plus b. So x equals g inverse of y, just like what we did in our last example, y minus b over a. And dx over dy is simply 1 over a. So f sub, I'm going to use different color. See, this quantity you already know. So f sub y is, see how I make use of this. So f sub x, g inverse of y. So it is basically f sub x, g inverse of y. G inverse of y is basically, you just pass this function y minus b over a, and then magnitude of dx over dy, and x equals g inverse of a. So which is basically, this quantity is 1 over a, so 1 over a, it has to be magnitude, and then you have f sub x, y minus b over a. And that is what you would be using for your extra credit problem. Okay? So this is the function that you will be using directly for your extra credit problem. So I'm going to show you the extra credit problem now. So this is the example. This is the example. You have x is a Gaussian random variable solution. Look, here x is a Gaussian random variable, so therefore x is a Gaussian random variable, mu sigma square. Please pay attention. So even though some part of the code is given, but there is additional part that you need to do. So please pay attention to this part. Okay? So the expected it is going to be 5 points for this problem. So what you do, because this is a Gaussian random variable, so you know what is f sub x, which is 1 over sigma square root over 2 pi e to the negative half x minus mu over sigma square. So you know s sub x, which is negative infinity to positive infinity, and you know g of y equals g of x, which is ax plus b, and there are conditions here. So you need to find what is f sub y. PDF f sub y equals 1. So I am going to directly use the previous formula right here to get PDF. So you can actually follow the previous step. I'm just going to directly write down. So f sub y is going to be 1 over a, and then 1 over sigma square root over 2 pi, and then e to the minus half y minus a mu plus b over a sigma, and this part is going to be squared. Okay, so this is your PDF, and which is basically y is a Gaussian random variable, mean is changing, which is a mu plus b, and variance is basically a squared sigma squared. So I just used the previous formula and I wrote the answer directly. Okay. Now my handwriting is too bad. So f sub y, I'm just writing one more time. 1 over a, and then 1 over sigma square root over 2 pi e to the negative half y minus, this is y minus a mu plus b over a sigma, and this guy is squared. Okay, so I just wrote this part one more time. So basically, it becomes another Gaussian random variable with parameter a mu plus b. This is the mean of y, and this is the variance of y. Okay. I gave you some parameters. Okay. In 3 minutes, I'm just going to finish this chapter with this extra credit problem, guys. So I gave you these 2 parameters. Okay. Number 1 task. Number 1 task, please pay attention. I gave you these parameters. Mu sub x equals mu equals 0, sigma sub x equals sigma equals 1, a equals 2, b equals 3. Okay? You simply type and understand this code, and your plot should look like this. Okay? Your plot should look like this. I just need the Python code. So this is number 1 task. Number 1. Number 2 task. Number 2 task is that you will have some programming experience as well. Okay. What I want on top of this graph, okay, on top of this graph, I want you to find the probability I want you to find the probability so your program should be shading, so you have a different shading here. So this is the probability, and it should display what is the probability. So you find probability of -2 less than x less than or equals 2 equals what? Your plot should display this one, and the other one is from 2 to 4. So what you do, I'm going to use this color. So from 2, from random variable y, you shade this part. You shade this part, okay? And this part is the probability that 2 less than y less than or equals 2 equals what? Okay, you can take pictures so that you know exactly what you are supposed to do. So first is,
Wait, what was the balance for the pink one, part two, is that entrance? This is
oh, 2 to 4 actually, sorry. 2 to 4. Yeah, 2 to 4. Thanks. Yeah, it's 2 to 4. So here I did shade. So you can shade them, and then you will have to make it just to give you an idea. You will have to make use of the CDF, standard CDF function with different parameters. Okay? So you will have to make use of, I'm just giving you a hint, make use of 5 with normalized parameters. Okay? So then you should be able to find this. So I will give you the sign up sheet. You don't need to show me what you will need to do. Two things, two deliverables. One is you sign the sign up sheet after coming back from Spring Break on Friday, and you submit the Python code, and I'm going to open the Excel previous. Clear? Is it crystal clear? Yeah, good. Okay, good. Did you take picture of this one? So if you have phone, like you can take pictures.
Oh, yeah.
So you start with the existing code and then you modify. Clear guys? So travel safe, those who are traveling and enjoy your spring break. I will see you after the
He said don't copy hers, you copied Investor straight up. Yeah, I only changed how I tag my measurements.
Well, I mean, there was only like one series that I'm looking at thing. You just tell them.
I'm a